Great, so we just talked about acceleration, and now we're going to talk about a concept called force. May the force be with you, as the famous words of some of our Star Wars characters and Star Wars gurus out there, you know what I'm talking about. So, may the force be with you. What exactly does force mean? Force is defined as a push or pull acting on an object. So you push something or you pull something and that object is going to move. There's several fundamental forces in the universe. One of them, which most of you know, is gravity. So the reason why we stay here on Earth and don't float away is because of gravity. All right, gravity pushes down on us. There's something called electromagnetic forces, and we also have weak and strong nuclear forces. When it comes to the motion of everyday objects, the forces of interest are, so when everything that we see throughout our daily lives, there's a couple of different forces that interact, okay, that we come in contact with. So number one is being gravity. Gravity is always present in our life and will never go away. It reflects your weight when you step on a scale. If it goes away, then I guess we'll be floating in midair. So gravity is a big one. We also have friction. So think about if you rub your hands together, okay, you have friction, okay, you're creating that heat. So when things slide together, and you also have something called applied force. So we're going to talk about that today a little bit. Your applied force is a force that a person or thing applies to an object. So that would be a push or a pull. Forces cause all motions. So objects will not move unless a force is applied to it. So things do not just float in midair. Okay, there's something acting on it. So these are the rules of physics. There has to be something pushing or pulling on that object to make it move. Every time the motion of an object changes, it's because a force has been applied to it. Force can cause a stationary object to start moving or a moving object to change its speed or direction, or both. A change in the speed or direction of an object is called acceleration. And we learned about that in last class. Or I'm sorry, in the last set of notes. Let's look at an example. So we have Colton here in this figure below. He's getting his scooter started by pushing off with his foot. The force he applies to the ground with his foot starts the scooter moving in the opposite direction. So he's pushing one way, the scooter's going the other way. The harder he pushes against the ground, the faster the scooter will go. So this is an example of an applied force. Force is a vector, or a measure that has both sides and direction. So we talked about, talked about two other vectors, velocity being a vector with your arrows, and we have acceleration being a vector. So now we're adding a third vector, which is force. So Colton pushes on the ground in the opposite direction that the scooter moves. So that's the direction of the force he applies. He can give the scooter a strong push or a weak push. That's the size of the force. Like other vectors, a force can be represented with an arrow. And you will see here in the next slide. So if you look at example 1, you have force A and force B. If you think about it, and we've talked about this with velocity and acceleration, which one, force A or force B, is going to be the stronger force? Force B is going to be the stronger force because it's the larger force, or the larger vector. You look at example 2, you have force A and force B. They are pointing in opposite directions, but force B is equal to force A. Okay, so there might not be much interaction going on that object. They kind of cancel each other out. But in example 1, you have force A and you have force B, so your object will most likely move to the right. As with your velocity vectors, the length of each arrow represents the strength of the force, and the way the arrow points represents the direction of the force.